Very good morning to everyone. As part of our continuous learning journey, we are moving to the next step in Python. So the things that we are going to discuss today is typecasting. Typecasting is something is very common in every programming language. When you want to change type of data that you have from one type to another, we in that moment we need a casting. So the typecasting, casting a data type from one to another is very common in a programming environment. So the language that we are using for programming should support it. The Python does that. We have three major functions to cast the type from one to another in Python. They are int, str, and float. When you put something inside the int function, some a float or string inside the int function, it will be converted to integer, right? Similar way, when you put something inside an str function, that will become a string, right? So like that, we have these three major functions. As far as the Python is concerned, there is no explicit declaration of variable right now that we all know, right? We don't declare a variable as an integer or string or float. The moment we initialize the very first value, or moment we initialize a name with some value, in that moment only the variable or object is created in the memory, right? Again, they have a in Python follows certain something like whatever the variable reference that you use in the program is just a name, right? The moment you assign a name to a value, that means when you assign a value to a variable, at that moment in memory, the object for that value is created, and then and the name, that the variable name that we are giving, that is used as a name to access that object. In that way it works. It is not something similar to, it is not exist in other programming language like C++, right? There we used to allocate a memory, and then we attach that variable name with that memory. Even whenever we want to reference that object, right? Whenever we want to refer that memory, we use the variable, right? So that variable and the memory locations cannot be detached. That means they cannot be separated. But when it comes to Python, it is possible. You have a variable name initially. For example, uh, a is equal to 10. You are assigning the a variable a to the value of the value 10 to the value 10 to the variable a, right? At that moment, actually, in the memory, they are creating a memory location to store variable the value 10, and then they link the name a from the name a to that memory. Okay, this is common. This exists in other programming language as well. The beauty is in the next line, if you say a is equivalent to 10.8, which is float, the first thing is an integer, that the value 10 is an integer. But when it comes to the second line, the same a is given to 10.8. What they will do now? Are they going to change the data type of the existing memory location from the integer to float? The answer is no. So they create another object which can using that in the memory. Using that, we can store this 10.8. Then they connect the variable, the name a that we have right now, that is linked to the value 10.8 now. It is no more linked with the value 10. So like that, now the objects and names are detached. When it comes to the value 10, the value 10 is detached from its name, right? So it is in that way. So they do right now. That's why we don't have any explicit declaration in Python. But there are certain what is it, certain environment or certain task we have to do a type casting from one data type to another. Then how we do? Right, here are certain example. Here are some example that I have, like sum equivalent to 1.6 plus 1.7, and then I am printing the result. Can you guess what might be the result of this expression? The result of expression, as we didn't say, can you guess that one? Is it a 3.3 or 3, what it is, or 2, what it is? As I told you before, there is no explicit declaration of variables in Python. The sum is just a name that we give for the result that we get when we add 1.6 and 1.7, as 1.6 and 1.7 um, or a float. The result will also be a float. So the result is 3.3, to which the name sum is linked. So when we print that, we used to get the result as 3.3. Okay, moving forward. The next statement that we have is sum is equivalent to int of 1.6 and int of 1.7. So in case of CAPL or C, we used to put the int inside the bracket and the value outside the bracket. Right now, that is how we used to do. But here it is inverse. So we have to put the value inside the bracket and the data type outside. So I am converting the 1.6 to int and 1.7 to 7 to int. So it becomes an explicit typecasting. So when we do like that, what will happen? So as we are explicitly converting 1.6 to integer and 1.7 to integer, what will happen? When you convert anything to an integer, its fractional part will be ignored. Its decimal part will be ignored. They won't consider, right? So 1.6 will become 1 and 1.7 will become 1. By adding those two, we will get the result 2. That will be the result of that will be the result of your sum, right? Then I have a third statement. In that we have, now the data type assumed for sum is an integer, not a float. So in the previous case, we just add 1.6 and 1.7, we get the result as float. In the second case, we convert 1.6 and 1.7 to integers, and then we assign the sum to it. When we do like that, so now the sum is an integer one, because its two inputs are the two input to add the result or integer. So the result will also be an integer. Then we are having an explicit conversion of 1.6 to integer, 1.7 to integer. Then there is a float variable, which is 9.0. The result will be, when I add that one, as I told, 9.0, so it is a float right now. So I think you instead of putting 0, we can make it like that. 9, but the value is integer, but I am doing typecasting to float so that the 9 will become 9.0. The end result will be 11.3, I believe, if I'm not wrong. That will be the result, right? In the third case. The fourth case, we have 1.6 explicit conversion to integer, and then 1.7 explicit conversion to integer, and then a 9 integer. Here we don't use a float, so here it is an integer. So all the three inputs that we have in this expressions are integer. The result will be integer. So the result will be the 11 in this case, right? That's how it is. So now you understand, right? So the typecasting means changing data type of one entity to another one. It is very common in every programming language. Doing typecasting is very common. So the Python support that as well. In order to support it, it has three major functions like integer, str, and float. The integer do an integer conversion, str convert things to string, and float does it to for decimal number, right? So that is how it is. So let us try this one. Let me bring Python to try this. This is my working directory here. Right, so what I am going to do, I am going to create a Python file using Notepad. I call that as a casting.py. Right, so here it is. So let me copy and paste these things. Right now, as far as this is like, understand, type casting in Python cannot be like this. All right, we have different things. Right. Here it is. What int plus int plus int plus what plot plus int plus, right. So that is this. Let us interesting. Right. So initially we have a float plus plus, the result is float. Then we are converting those two entities into an integer, then we are adding it, so we are getting 2. In the third case, interesting. Yeah, because the 9 is an integer, we convert that to float so that it will become 9.0. And integer conversion of 1.6 and 1.7 will become 2. That is, this will become 1, this will become 1. So the added result will be 2. 2 plus 9 is equal to 11.0. As this one is float, the result is float. Right. The next one is we have a in 1.6 and 1.7, we are converting them to integer, and we add an integer to it so that the result will be an integer, right, which is 11. That's all. So now we have explored how to work with, how to do typecasting in Python. Okay, team, that's all for today. Let me catch you with more detail in upcoming session. Thank you. Thank you for watching.